you very much. So my name's Katherine Stanley, and today I'm going to be talking about running Kafka in Kubernetes. The reason I have my Kafka Summit London top on is actually I presented this at Kafka Summit London. So I would encourage you all to ask questions as we go through so that we can kind of tailor it to the audience in the room, especially as you guys all managed to make it. So I'm very thankful that you made it. I'm also thankful that I made it because it was looking interesting last night when my flight got cancelled, but we're all good. So what I'm going to do is actually first introduce the product that I work on, but there is a good reason for this. So this is Event Streams, IBM Event Streams. It's a fully supported Kafka offering. You can see here our UI, and we have some additional value add capabilities on top of Kafka that we provide. So things like our UI, some monitoring tools, that kind of thing. But the key thing for this talk is that Event Streams is actually built on top of Kubernetes. So this is the kind of real world experience that I have of trying to get Apache Kafka running on Kubernetes. So where did this all start? Well, for me, this actually starts looking back at moving from monoliths into microservices. So my role at the moment, I work on IBM Event Streams. Generally, I'm a developer. I try and come out and talk at conferences and things as much as possible. But in my previous role, I actually worked on the WebSphere application server, which is our Java application server at IBM. So for me, I saw this whole journey of kind of moving from monoliths to microservices. So we have our monolith, and then we split it up into microservices. Maybe we had a service registry, and these are all talking now with REST. And they each had their own database. And this was a kind of movement and experience that we've been seeing people going through. And this, of course, led to the rise of containers. When you're running lots of different microservices in lots of different places, it makes sense to be able to deploy them easily again and again and again. And particularly in the move to cloud, we're wanting to deploy our microservices not just in the cloud, but also run them locally and then quickly update them and not have the problem of, well, it worked fine on my machine, but it didn't work when I went into the cloud. So the rise of containers provides encapsulation of dependencies, it provides isolation, and it gives you that dev prod parity so that you can run everywhere. But the rise of containers also brought about a few different problems. So one of those is routing. So I had my picture of the service discovery. How do these containers talk to each other? Now that we're in the cloud, we don't want to have just a particular IP address, because if that app goes down, how do all of my other services know where to call? And also handling failure. Hopefully a lot of you in the room here know, because you're familiar probably with Kafka. Kafka is really good at handling failure, and in a container world we have to think about how do you handle failure. You've got to expect that an application will go down, and what are you going to do as a result of that? And that's where Kubernetes comes in. So general show of hands, who here is already familiar with Kubernetes? Yeah, most people happy to like using it already in production? Yeah, okay, not so many people. So in case you didn't know, Kubernetes actually means helmsman in ancient Greek. So you can think of Kubernetes as the tool that you're going to use to steer your containers in the right direction. And it's declarative. So the key piece here is you describe the desired state of a system and Kubernetes will make it happen. So Kubernetes will be doing things under the covers all the time to make sure the state that you've requested is currently there. Some general terms, just so that we're all on the same page. We've got a pod with some containers. And you could have more than one container in a pod. Generally, you just have one. And then to scale out, you create multiple pods that are exactly the same. So here we have 3. And the first term that people tend to come across for how to manage these pods is called a deployment. So we've got our deployment, but that just describes how to stand up an individual pod or separate pods. So in Kubernetes, I said it's doing some sort of handling for you. If one of these pods were to go down, the deployment will make sure that more of them have stood up. But from a routing standpoint, we use something called a service. So because each of these pods are supposed to be the same, and the reason we have 3 is for scaling, we want to have something that abstracts away what other microservices are calling into. So they shouldn't call directly to these pods. Generally, you have a service and they route across through the service. Services and deployments are defined like this, so it's just a YAML file. Once you've written these a few times, then hopefully you'll have some templates to get started, because it can take a little bit of time to write them every single time. But you can see here at the top we've got it defined as a deployment, and you provide things like the number of replicas, so that's the number of pods. And then for a service, you can see it says kind service, and you can provide things like where to route to. So we've got our Kubernetes, but at the same time, we've been having this shift from being data-centric to event-centric. And because we're at Kafka Meetup, a lot of you will probably be familiar with this shift that people are starting to look at. Rather than focusing everything on having those individual databases per microservice, people are saying, well, actually, I still want a common view of the world, and I don't want to be responding to something that happened yesterday or last week. I want to be responding to something that happened within the last second. So there's this general shift happening, and you can see it's actually been happening for a while. This picture is actually from 2017, of shifting away from being data-centric to being event-centric. So we've had this rise of microservices, containerization, and then bringing in Kubernetes to help you manage all of that. And then over here, we sort of have this rise towards being more event-centric. And we're seeing a lot of customers moving to this sort of model where they're saying, actually, I want to have an event backbone at the core of everything that I do. Maybe I've got some sources coming in, doing some stream processing on those events as they're coming through. I might have an archive that I'm going to go back and replay events, and I might have some notifications. But really, the core piece here is shifting away from having all these separate databases and actually having an event backbone. And that's, of course, where Apache Kafka comes in. So this is the core event backbone that we're seeing at IBM lots of our customers are picking up. So I'm going to go over a few basics of Kafka. I'm hoping, because it's Kafka Meetup, this will be fairly familiar. Who here thinks they already know how Kafka works? Yeah? People used Kafka? I asked this question at the Kafka Summit, and a lot of people seem to think they know what it was, but hadn't really used it, which was kind of interesting. But we have a topic, which is the core grouping of types of events in Kafka. It's we've got all of our records here, so this is our stream of events. And it's append only, so you always add on to the end. And they're numbered here, and that's known as your offset. Within a Kafka cluster, you tend to have brokers, and generally you'll start with at least 3. And the brokers are your individual machines that are running Kafka. And we'll see in a minute why it's important to have 3. So these are our kind of central piece of our Kafka infrastructure that we're going to have to start thinking about running on top of Kubernetes. So within our cluster, we then have our topics, which are split by partition. So we have the partition separated over the different brokers, and of course this is for scaling. So this is to make sure that you can have different applications putting onto different partitions. So rather than having all of your events for topic A coming to this one broker, it wants to be spread across the different brokers. So this is something we're going to have to think about how we enable this as we move across to Kubernetes. As well as being very scalable, Kafka is very good at being highly available as well. And it does that, of course, using leaders and followers. So we have topic A, partition 1. This is currently the leader. And then the same topic and partition, so the same records are being copied across onto the other brokers. And the key piece here that we're going to have to remember a little bit later on is actually all of the applications that are sending events into Kafka and pulling them from Kafka, they have to talk to the leader. The replication is happening under the covers. Kafka is doing that under the covers. So we have to make sure that that's possible, but the actual applications that are coming in externally must talk to the leader. And then, of course, if one of these brokers were to go down, we have a copy of all of your records, which can then become the new leader. So that's how the high availability comes in. I'm assuming you guys are fairly familiar with these terms, but producer is what we call applications that are sending events into Kafka. And then we have consumers that are pulling from Kafka. And consumers often run as part of a consumer group, and they will basically work together to read all of the records from a particular topic. So, I've given you an introduction to Apache Kafka, which hopefully was just a reminder. And then, of course, Kubernetes. And because we've had this shift towards being microservices and having also being event-driven, it's now actually a really good time to start looking at why wouldn't we run Kafka on top of Kubernetes so that we can actually run everything just in the same place. So what I'm going to do in this talk is basically give you what are the key things that you should remember about Kafka and Kubernetes so that when you first go to stand up Kafka on top of Kubernetes, you won't immediately fall down a hole. Kafka is very configurable. You can set it up in really interesting ways, but there are a couple of key pieces that you need to make sure you understand in order to stand up something that works at all, because then once you've got that piece, then you can start taking the next steps of making something that's really, really effective. So first, let's look at Kafka pods. So I don't know about you, but the first thing I do whenever I try and stand anything up in Kubernetes is I do kubectl get pods wait to see if anything's actually running at all. So this is our first aim when we're standing up Kafka on Kubernetes. And I'm looking for it to say ready and status running. So first we'll look at how do we achieve that for Kafka. So this is actually done using Kubernetes health checks. So Kubernetes has two different health checks. It has liveness and it has readiness. Often you'll see people set them to exactly the same thing, which in a simple application probably is okay, but it's useful to know the difference and to make a specific choice when you're standing up Kafka. So liveness is really a question of, is the container running? Is my app functioning at all? And the key piece here is that if your liveness check is failing, Kubernetes will take some action, and what it will do is restart your container. So you can see that if you don't have your liveness check configured correctly, Kubernetes will just keep restarting your containers pretty much forever. It will back off slowly and wait a bit longer before it does the restart, but this is a key one to get right. The second one is readiness, and this is when is your application ready to receive requests? So this comes back to where Kubernetes handles some of the routing. So I said you have this service that's routing to the different pods. Well, what Kubernetes will do is if your readiness check is failing, Kubernetes will basically remove that pod from the list that it's routing to. So even if your liveness check is passing and your container is running and absolutely fine, if your readiness is failing, Kubernetes will never route you to it. And you can try this out really easily yourself, just standing up an app and just setting a readiness endpoint that always returns 500. And you'll see Kubernetes will never send you to it. So there is a distinct difference here between liveness and readiness. For Kafka, it's useful to define these. So when we run Kafka in Kubernetes, we actually have our own extra container that we run that provides the health checks. So because Kafka can be run not in Kubernetes, a lot of people are just running it sort of native, it's not something that is provided by Kafka. This is something you kind of have to add on top yourself. So you can see here, this is just a snippet from our Kubernetes files where we've got our readiness and our liveness endpoint. So for liveness, we're checking to see, is the port open that Kafka is supposed to be running on? And does it respond to the basic Kafka protocol? So if the Kafka protocol returns back okay, we can see Kafka's kind of running. We probably don't need to restart the container, sorry. So that's probably a good enough check for your liveness. Readiness is a little bit more interesting, and it's kind of up to you of what you view readiness is and what else is going on with your applications in your system. But one of the things that we actually check for, which I think is an interesting one to think about, is your number of in-sync replicas. So the reason for this is because there's a setting which is min in sync replicas. And that is the minimum number of replicas that must be in sync for a partition of the topic to be considered available. So what that means in picture form is that if I have 3 brokers and I've set min in sync replicas to 2, and at the moment I've got 2 brokers that aren't in sync and 1 that is in sync, what Kafka will do is it will prevent producers from producing to your brokers. The consumers can still consuming, but only from the in sync one. But anybody that tries to produce will basically get back an error message. And they do get back a useful error message that explains something about it being unavailable due to the number of in sync replicas. So this could be an interesting thing to look at from a Kubernetes point of view. I potentially don't want to immediately, if I'm in this situation where the brokers can't produce, tell Kubernetes I'm not ready, because then I'm losing that useful information from Kafka that it's handing back to the producers. But it might be that actually within your system, you have a lot of monitoring of when your pods are responding to say that they're not ready in Kubernetes. Kubernetes has this whole idea, often systems will warn you if things aren't ready. If you do get pods, you can see it really easily. So if you find that for a long time, your brokers, the number of in-sync replicas is lower than your min in-sync, you might want to consider reporting themselves as not ready. And then what you can do is have a trigger based on Kubernetes pods saying not ready to say there's some sort of problem here. So it does depend on your scenario. It might be that for you, any producers not being able to produce you want to know about it straight away, and so you immediately flag it as not ready. Or it might be you want to leave a little bit of a gap. But these are the kind of things that you can start adding into those readiness checks to make sure that you're not just verifying, do I think Kafka is vaguely running, but you're really verifying, can my producers, consumers send messages in, can they pull messages out, is everything looking good, and I'm expecting Kafka to continue working as normal. Yeah.
Do you check that on a particular topic or on all topics? Because the min-in-sync replicas is something you can configure for topic, right?
Yes. Yeah, so for those of you who aren't aware, you can configure it broker-wide, and then you can configure it per topic as well. So it's up to you whether you check all of the topics or whether you say these are particular topics that we care about and check those. This is where it kind of, because Kafka is so configurable, you have to kind of configure Kubernetes as well. But it's useful to know that a lot of the Kafka settings you set at a cluster level, and then you can sort of override them at lower levels. Yeah.
I also have a question, if you're ready. So I was wondering, the liveness and readiness probe I can imagine very useful if you're like a stateless thing application, but as the consumer needs to talk to a specific broker because it needs data from a certain partition, what good does it do a consumer that the routing doesn't work? Because if Kubernetes says this pod is down, then the route it gets a 404 or something. So how would that work in practice if they're down? So
the readiness check is really for the person who is managing the Kafka cluster. So from your consumer's point of view, they'll keep trying to pull down, and actually, so you can see here, all of the Kubernetes routing, I don't actually know whether it will. I think what will happen is when it tries to do the heartbeat, it won't get through. But the consumer will still be able to talk to the one in sync replica. This is the slightly interesting behavior. If all of the brokers go down, you'll know about it pretty fast, I would imagine, because everyone will be telling you, whether it's you running it or whether your clients or whatever have their applications. This is the interesting scenario, I think, because your consumers can still keep going, and this broker you could mark as ready, but you've got 2 that aren't ready, and that's what you should flag. So that's why I've pulled out this particular scenario. If everything went down, then your consumers would disconnect as well, because when they try to send the heartbeat, that wouldn't work. This setting is an interesting one, I think, because it's one that if you get it wrong, because you can set this to min-in-sync replicas is 3, and then as soon as one goes down, then you're in trouble. So it's an interesting setting to know about for Kafka, because it can make quite a difference to how your cluster performs. And then if you think about it from a Kubernetes point of view as well, there's like an extra layer of intricacy going on. And I think it's with anything that you're looking at from a readiness point of view, this is why I like this example, it's interesting to think, what does Kafka do already? Because Kafka already handles this situation quite nicely, that it says, don't produce because you're going to get ahead and then we're going to lose stuff. But that doesn't necessarily help you if you're busy monitoring Kubernetes. So you've got to know, what's Kafka going to do, and am I going to tell Kubernetes about that, or am I going to keep it on the Kafka side? Yeah.
Is it actually a good practice to connect to your brokers via the service address, or directly on the on individual brokers?
So I've got a bit about routing later on, so let me know if I don't cover that.
Sorry, I'm very new to the Kafka, and
okay.
I'm not sure, like, is it a good... Right now we are using, we are sending a query to Zookeeper to see if the Kafka has registered itself into the Zookeeper, and using that as a health check. Is it a good practice, or is it wrong? Or?
So with our health checks, we do go and talk to Zookeeper as well to understand what's Zookeeper doing, what information does it have about Kafka's running and stuff. So it's definitely a useful thing to be looking at Zookeeper as well. It does depend a little bit on your setup and what you care about, but definitely the interesting thing is there's an extra piece on top that you wouldn't necessarily think to add, because I think a lot of people do set their liveness and readiness just the same, and then they walk away and go, oh, I'm done. But there is a difference, and I think there's quite a lot you can do in your readiness probe, and it's up to you how many layers you want to build up. But you can have quite advanced readiness probe checks that go around to really make sure if it says it's ready, then there should be nothing wrong, and everything that we would expect to be lined up has been lined up. Okay. So now that we've got our pods, they stand up and they sort of run. This one kind of goes before, but I think it works better talking about it in this order. Now we have to think about how we're going to manage the pods. So I talked about a deployment before, and the fact that generally when people start being introduced to Kubernetes, they get introduced to a deployment and the fact that you can set a number of replicas and they stand up, and that's fine. For Kafka, that doesn't quite work. Instead, what you want is something called a stateful set. So you can see here the kind at the top there is set to stateful set. And the key piece for a stateful set is that when it stands up its pods, it maintains a sticky identity for each pod. So the pods get a number. They get an ordinal number, it's called. So if I have 3, I'll have 0, 1, and 2. And they're specifically designed, the key is in the name, to be stateful. So they have persistence via persistent volumes. So although Kafka does do a lot of its recovery and things by having replication, it is good to have a backup so that you can pull the data back from a storage if needed. And that's where these stateful sets and persistent volumes come in. And we also make use of this for updates as well, because stateful sets have a nice way where if you do updates, you can bounce one pod at a time rather than it sort of bouncing everything. So to explain how the persistence volumes work for Kubernetes, I'm not going to go into detail about what your specific storage option is here, because it kind of depends where you've deployed Kubernetes. But if you assume we have some sort of storage here, which is my data, what you define is something called a persistent volume. So this is a YAML file for Kubernetes, which is called a persistent volume. It creates an object in Kubernetes. And the persistent volume basically describes what you have here. So it will describe how much space it's got maybe. It might have the information about what this location is / my data. So you describe that to say, this is my Kubernetes abstraction of what my underlying storage is. So you could switch out the storage if you wanted to as well. Then when we stand up the pod, we give it something called a persistent volume claim. So the persistent volume claim is associated with the pod, and it's basically a declaration of what the pod needs from a storage point of view. So how much space it's expecting, what location in the container in the pod we're going to mount the storage onto. And what will happen is when your pod starts up, the persistent volume claim will bind to the persistent volume. And the key piece is for a stateful set, if your pod goes down, the persistent volume claim stays there. So then when the pod comes back up again, it will actually pick up the same persistent volume claim and have the same underlying storage. This is just useful to know from a deleting point of view. If you delete your stateful set, then your persistent volume claim and your data will all actually stay there. And then you'll have to go delete your persistent volume claim separately if you really want to get rid of everything. But that is done on purpose so that your pod can come back up and pick up the same storage. If you were running a standard application and you were maybe only using your storage for storing logs, might not be the end of the world if it picks up a different storage. You might have multiple log files separated over different places, so maybe that's a bit annoying to go fetch them all, but it potentially doesn't break your application. But for Kafka, if you don't use this system, you will see some interesting effects. Particularly, you'll see this message: inconsistent broker ID exception, configured broker ID 1 doesn't match stored broker ID 0 in meta.properties. So I know a lot of people who've started off with Kafka and Kubernetes, and this is one of the first things that they then run into. And the reason is because when you start up Kafka, you provide a server.properties file, and in that file you provide a broker ID. Because in Kafka we have this idea of the different brokers owning different topics, they have a leader and then they have replicas, they need to know which one's which. So that's where this ID comes in. And you can see it says here that it must be unique. So they have this unique ID. But the thing that's not immediately obvious is actually when it stands up, it will log out what it thinks the ID is, but it will also create a file called meta.properties in its storage, and it will put the broker ID in there. And so if you see this message that says that your IDs don't match, what's probably happened is you previously had a broker ID meta.properties file written, you stood up your Kafka broker, it's logged out what it thinks the ID is, then it's looked in this particular file and it's gotten a different answer. And so that's where you'll see that message. So our stateful sets actually solve that problem for you. My phone's buzzing. So we've got our pods, we've stood them up, we're happy that they're alive and they're ready and everything, and we're handling running them in different ways. We've got the stateful set so that if the pod goes down, it comes back up. We're not going to run into inconsistent. So now we actually have to decide where to deploy them. So generally for Kafka, we have this idea of the different brokers. Can you see that okay? Just about. So we have our leader and we have our two followers. And I talked about how if one of them goes down, then the other one will pick up the leader, and this is how we have fault tolerance in Kafka. Well, in Kubernetes, what we want to do is make sure that if the broker goes down, the other brokers haven't also vanished. And so the most likely thing to happen is your node in Kubernetes goes down. So that's where affinity and anti-affinity comes in. So this is another example of one of our Kubernetes files that we have for our product. And you can see here that we've got anti-affinity with Kafka. So basically what we say is that if we're going to stand up 3 Kafka brokers and we've got 3 Kubernetes nodes, we will put 1 on each node. And then if we assume the most likely thing to go wrong in Kubernetes is one of your nodes goes down rather than the whole thing, then that should mean that you've got 2 other brokers, they can carry on, you can fix your other node, and then you're good. The interesting thing to note is Kubernetes has this built in. You can just add pod anti-affinity and it will happily do it. But it's just a preference. So Kubernetes will not force this to happen. If it doesn't have enough nodes to spread them out, it will put them on the same one. So you have to make sure that not only have you got this set up, but that you keep an eye on what your nodes are doing, because you could get in a scenario where 2 of the nodes say they're not ready, Kafka moves Kubernetes moves all the brokers across, so they're all running on the same node, that goes down, and then you're still in trouble. So you want to define this anti-affinity so that they're running separately, but it is just a preference. So you need to make sure you're continually aware of what's happening under the covers. Then we have the opposite, which is pod affinity. So this one potentially isn't as crucial for fault tolerance, but it's useful to sit your zookeepers next to your Kafkas. So when we run 3 Kafkas and 3 zookeepers, we'll generally try to aim to have them next to each other and spread them out across the different nodes.
One thing that I should mention that Kubernetes has an affinity type that it says required unit scheduling. So if one of the nodes isn't available, it will not schedule the pod on any other node.
Yes, but at that point you then don't have, so we've chosen preferred. I don't know if you can see it on here.
Yes, it's not after.
Yeah.
Third line.
Yes, there you go. So we've chosen, and the reason that we've done that is we would prefer to have all the brokers running than to have not one scheduled at all. So that is right, that is a choice that you can make. But I think often people copy paste these YAML files and then don't fully read what it says. So you can see this is just a screenshot of me doing get nodes on my particular install. So you can see I've got one which is the sort of master proxy etcd management. This is just a test system, and 3 workers. And if I look at one particular worker, then you can see basically what I end up is 1 Kafka and 1 zookeeper on each of them. So we've now got our Kafka pods. We're happy that they're ready. We're happy we know how to stand them all up using the stateful sets, and we've got them separated across. Then we need to access them. So I talked before about the fact that in Kafka, all of the producers, the consumers, they have to talk to the leader. So this is quite a contrast to what I said earlier when we had Kubernetes and we had one particular service where it's load balancing across the different services. Actually in Kafka you almost have the opposite, where what will happen is the app will come in and it will talk to any of these brokers and say, I want to produce to topic A partition 1, and it will basically get told by Kafka, oh yes, you need to go talk to this person. So Kafka likes to own some of the routing here, and we have to make sure that Kubernetes doesn't stop that. And it comes back to the stateful sets. So stateful sets request that you also have something called a headless service. So this is a generic service, but it has a cluster IP of none. That's the key setting. And you can see here that I have a selector with a 0. So what this means is basically rather than saying I'm going to have one service and that's going to just load balance across all of my different pods, what you can have is have a headless service for each of your Kafka pods and have them routing by selector. So this one will route to my 0 pod of Kafka because they're in a stateful set, so they have this ordinal number that they can relate to. So you can see here as an example, if I do get service, I've got one headless service for each of my Kafkas. So we've got these different services, but there's another interesting piece that is worth being aware of, and that's the difference between, yes?
About the previous slide, having different services, I have seen the Helm charts for like Confluent Kafka, and I don't think they don't use multiple multiple services for the Kafka nodes, and I'm wondering why you think it's better to have multiple services for each Kafka pod.
So I haven't looked at the Confluent one, so I have no idea how they work. So for us, the reason that we have these individual services is just because then when we do routing internally, we can route to a specific service rather than having to route to the IP of a pod, which I think is the other option, which then could change if the pod comes up somewhere. So I don't know how it works when you don't have the 3.
Yes, you can use just the pod's name. Like use like
oh, I see. Yeah. Okay.
0, like,
yeah.
Kafka headless service.
Okay. Yeah. So if you're routing to something that's called headless service, then it probably is routing through a service.
Yes,
you might just not see it.
And,
oh, I see. And then it routes. Okay. Yeah. So I think it's kind of up to you. So this is the way that we run with it anyway. But the key piece from a Kafka point of view that I think a lot of people don't realise is happening is there's a difference between your listeners and your advertised listeners within Kafka. So the listener setting that you will have set up in Kafka is the address for your Kafka to listen on. Your advertised listeners is basically what you tell everybody else to come in on. And that's where it gets interesting with how you configure it with Kubernetes, because when you're just broadcasting, this is the port that I'm going to listen on, that's not necessarily what you want to tell applications that are coming in and wanting to produce and consume. So the setup that we have in our, if we look at our different broker configs, so if you're curious, this is just our command line that we have. That's what cloudctl-es is. So I've basically listed out the broker configs for each of our 3 brokers. So you can see crucially that all of the listeners are just 9092, because I've just got a container, it's just listening on 9092. As far as it's concerned, that's the end of it. And if you run Kafka locally, you'll notice in the server.properties, when you run it, that the listeners has actually just been set to exactly the same as the advertised listeners. Everything runs on localhost 9092 or different if you're running them all locally, and it all just works. But when we're running in Kubernetes, we need to have this separation. So we've got them all the same for the listeners, but the advertised listeners, the way that we're doing it, is we've actually got some different ports here. So the way we've actually got it set up is we have, because we're expecting our applications to call in from externally onto this IP address, what we've done is just routed it by port. So we have a proxy, and basically when requests come in, we say, okay, if we know it's this port, then we know we need to route to the specific broker. It's up to you how you do the specific routing, but the key thing is you need to make sure that the advertised listener is the address that you want applications externally to come in on, and you need to make sure that Kubernetes isn't getting in the way and routing you not to that location. If you use a generic service and you don't go the headless service route, then you can actually have a setup that does work, because by chance at some point when the application is being sent back round and round, it will probably get load balanced to the one it was trying to talk to. And I actually talked to someone at Kafka Summit who said they thought that might be what was happening, because they were noticing quite a long, like really weird latency times between requests coming in and getting to the brokers. And they came to my talk and then they were like, I think that's what we're doing, is that they're just happening eventually to get through. So it is working, but it's much more efficient if you do it this way and set up the external listeners properly. If you're wondering, so this external piece, there was a KIP that came in where you can actually define different listeners for different things. So we actually provide internal listeners as well, so that if there's communication within our Kafka cluster, we set it up differently. But for this slide, I didn't include that.
Around 8 minutes, 8 to 10.
Okay. I think I only have like one more slide, so we're okay. So the last thing I was going to talk about was automation. Hopefully I've given you a little bit of a few things to think about when you're starting to stand up Kafka in Kubernetes. Often you'll find that you don't have to write all of this code yourself. So as you mentioned, there are charts out there. Obviously we have charts. I'll show you where you can have a look at those if you want to. It's useful to automate things within Kubernetes, and there are various different tools to do it. But it is worth being aware of what's happening under the covers so that you can debug if things go wrong. But from an automation point of view, we're actually currently using Helm. So Helm is YAML-based, very similar to Kubernetes. You define what Kubernetes things you want, and then off it goes. And specifically, we use it from an install and an upgrade point of view. So because our offering is on-premise and we give someone a package to install, they run Helm install, and it stands up literally everything. So it'll stand up all of the Kafka brokers, Zookeeper, our UI, all of the pieces. And the nice thing is, you can do a Helm upgrade, and Helm has hooks that you can add in. So you can say, before you do a delete, these are the things you need to clean up, or before you do an upgrade, I want you to change these specific pieces. So that's how we're currently doing our automation. Since we brought out our product and have been kind of developing it, there's been the rise of custom Kubernetes resources and Kubernetes operators, of course, which is another option. Helm is very much kind of more sort of, you write all these YAML files and then you can really see what's happening quite easily. Writing a custom Kubernetes resource or an operator is a little bit more involved. You potentially have to write a Golang app, but it can get you to scenarios where you could say kubectl get Kafka, and in the same way you can do get pods in Kubernetes, it will tell you what Kafkas you have. And if you add in the operator piece, so this top piece is really easy to do. This piece here is where you might have to start writing some Go code. Because if you do kubectl scale Kafka, you basically need to write an app that talks to the Kubernetes APIs that knows what that means and knows what to do with your Kafkas. So there are a few different options out there, but it's worth having a look around to see what other people are doing, because there are existing ways to install Kafka and Kubernetes that you can make use of. These are our charts here. So if you go to github.com, IBM charts, it's several layers down because all of the IBM charts are in the same place. And you can see our Helm charts here. So if you click through, you can have a look and see some of the things that I've been talking about today. This is for our community edition. So it's pretty close to what happens in the sort of paid for edition. But hopefully that's given you a little bit of a flow of some things to think about to initially start up Kafka and what readiness probes you could add, and some things to go looking for in terms of how you might add them. Understanding about stateful sets, which is something that often people don't come across straight away when they're moving to Kubernetes. Thinking about what is your Kubernetes doing under the covers and how do you make sure that your Kafka fault tolerance lines up with your Kubernetes fault tolerance, and then how you get access to Kafka as well. So that was all I had for you. Thank you very much. And more questions, please.
Thank you, Katherine. We have 5 more minutes for questions. Are there any questions left?
Yes.
Do you have any experience with cloud-native storage options to provide the persistent volume data?
So with ours at the moment, I think we're using either NFS or GlusterFS. Generally, one of the things I often say to people, which I think people don't realise, which is really interesting with Kafka, is actually a lot of people ask me the question, what does it mean for like performance if you're writing to disk and everything? But actually, when you set ACKs in your producers and you say, tell me ACKs all, I want to know when everyone has replicated the data, Kafka will actually return to say, yeah, we're fine, as soon as it writes it into memory, not when it writes it to disk. So actually your Kafka performance and how that's doing and whether it says it's replicated the data has very little to do with when it's written it to disk. So that's an interesting thing to be aware of, because I think people worry about that often, but actually Kafka's set up, its main way that it does persistence and the main way it does fault tolerance is through the replicas, not through having written it to a persistent store. Are there any more questions? If you think of any, feel free to come join me on Slack. Or there's a link to if you want to know more about event streams, and I'll be generally around as well.